22 has nothing to do with the mole ratio. But first of all, you have to write out the equation first. Right? You need to write out the equation. If you want to talk about mole ratio, probably with the mole ratio of the gases that is related to that. Because if you look at the gases octane, you can see the volume of the gas octane on this cathode is actually twice that of the anode. Yeah, so you have to write out the equation to find out which electrolyte will give you this amount of product. Now, remember we said that the dilute sulfuric acid. It's not just sulfuric acid. Any type of acid when it's being electrolyzed, it will always get you to the hydrogen gas and the oxygen gas, which is the water. Correct? Yeah. So if you look at question 32, the answer is D. That's because the volume of the hydrogen gas and the oxygen gas is always 2:1. Okay, so at the cathode, we will have the cation. What is the cation that's doing a discharge? That will be the H plus. H plus to give H2O and 2 moles of these electrons, right? So 2H plus. And then what about at the anode? So at the anode, we will have the O2, OH minus being discharged, 2H2O plus O2 plus 4E minus. Now, when you sum up these two half equations, you will see that the mole ratio of this hydrogen to the oxygen is actually 2:1. Okay, this is the overall equation. Can you see this is 2:1? So that is why at the cathode, they will have two volumes of the hydrogen gas, whereas there's only one volume of oxygen gas at the anode. Right, so you see this kind of setup, most of the time it will be the electrolysis of the aqueous acid solution or even the alkaline solutions. Now, on the other hand, you see that there are other options which talk about the concentrated solution. Now, usually concentrated solution, we said that the chloride ions will be discharged. So once the chloride ions are discharged, we will not have a difference in the volume of the gases octane, but in fact, it will have the same volume because chloride discharge will produce 1 mole of chlorine gas, and the hydrogen discharge will also produce 1 mole of the hydrogen gas. I think there's a question that shows the same volume of gases produced in this. There is question 25. So you see for question 25, if they have the same volume, then very likely it must have got to do with the chloride. And you know that chloride can only be discharged when the electrolyte is a concentrated solution. So behind your mind, you know that there's a possibility that chloride is being discharged. So what do? You look out for the options that has a chloride and there's a concentrated one, then you double check your answers by going through the working. So you see if it's a concentrated NaCl, you know Na plus when it will be discharged, it will only be the H plus ion. So H plus ions discharge at the cathode according to this half equation as written in the earlier question. And then now your anode will no longer be the hydroxide, but instead it will be the chloride that's being discharged to form the chlorine gas. That's it. Alright, so you can see the ratio is actually 1 mole of H2 and 1 mole of Cl2. That's why they have the same volume at both electrodes. Okay, so that's for 25. Alright, so let's take a look at question 21. Alyssa, answer the question, huh? Any questions, just one more. All right, now question 21, the answer, the answer is A. Now, why is it A? Now, first of all, it's a concentrated electrolyte, and it says which graph shows best shows the mass of the anode during this time. So, what kind of anodes are they using? They're using a copper electrode. This is considered to be an active electrode. Alright, active electrode. Now don't say that the copper is an unreactive metal, then you say that it's an inert electrode. In the context of electrolysis, copper is considered to be an active electrode. The only inert electrodes are the platinum, carbon, and graphite. Alright, so obviously at the anode, you'll see that the copper metal will start to get oxidized. It will turn into the Ce2 plus ions. So for question 21, what are the half equations that will happen at the respective electrode is that at the anode, you have the Cu2 plus undergoing the oxidation to form the concentrated sodium chloride. Right, to form the Cu2 plus ion because of the active electrode. Then what about the cathode? So the cathode, you have to look at the electrolyte. Which are the possible cations that can be discharged? You have the Na plus, you have the H plus. So it will be the H plus ions to be discharged by giving 2 moles of electrons to form the hydrogen gas. So what are observations that you'll see is that the anode will have a decrease in the mass because it is losing the electrons and gets oxidized into the Cu2 plus ions. Now the second observation is the electrolyte will turn to blue. It will turn blue because of the production of the Cu2 plus ion. Now concentrated sodium chloride is a clear solution because we know that it's a soluble salt. The solution is a transparent solution, but when we carry out the electrolysis, due to the production of the Cu2 plus, the electrolyte will turn blue. Right, the second observation is you'll see effervescence produced at the cathode because of the discharge of the H plus ions from the electrolyte. Yeah, so these are the 2 observations. So that is why graph A shows a decrease in the mass because the copper electrode will get smaller and smaller. Why cannot it be blue? Because, to go back to the yeah, this is also worth discussing. Now, whenever the electrodes get oxidized, it will always get oxidized according to this half equation, right? You see, the mole ratio is actually fixed. For every 1 mole of copper matter or the copper atom get discharged or undergoes oxidation, you will always be losing 2 moles of electrons. Now, don't forget electrons account for the electrical conductivity in the circuit. It also affects the mass of the element itself. Yeah, so there's a direct proportion in terms of the mass decrease and also the amount of the current that is being put in to cause the oxidation of the copper. Yeah, so you should get a linear graph, a downward sloping graph. Right, but if you choose B, it's a curve. The gradient doesn't show a constant proportionality. So this cannot be done. It's all because of the fixed mole ratio of the electrons that are being lost from the copper. That means in every 1 second, or maybe a fixed time, every a given time, you'll always be losing 2 moles of electrons. Got it? So that's how we get the answer.
I know what a scenario will be.
New scenario. Well, in the context of electrolysis, right, the mole ratio are all fixed already. Yeah, so it's not possible to get this kind of curve. As in, the graph cannot be a curve, it must be a direct proportion kind of a graph. So it's often a linear graph. So in the start of the process, we have put in the litmus solution. Now, what is the electrolyte that was used? It's a corn hydrochloric acid. So since it's an acidic solution, the litmus in the start should be red, right? Yeah, so it should be red. So after some time, will the litmus solution turn color? So we're going to look at what it will be discharged in the electrolysis of the HCl. So we're going to remove the H plus ion and the Cl minus ions because this is a concentrated solution. Right, so once the H plus ions and the Cl minus ions are being removed, then what's the remaining ions will be Na plus, OH minus, and the H plus. Alright, so when OH minus and H plus are combined together, you will get H2. Yeah, that's right. So that's why it removes red. H2 is neutral.
Yeah, I got that. It's H2O in the end. Then I chose A at first. But then I chose B.
You chose it back to B, why?
Yeah. Huh? I don't know. I thought because water needs to be like 7, then maybe the
Okay, understand. Some students or they chose B, right? It's because they give me this reason that because the H plus ions have been removed. So what's remaining will be more OH minus ions, right? and then lesser H plus ions.
I think
That's their thinking.
but then the H plus ion is discharged.
Correct, and then don't forget, you have two sources of H plus ions. One comes from the acid, the other one comes from the water, because it's a solution, right? Yeah, so there's water molecule. So actually, the amount of H plus ions and the OH minus ions will eventually be balanced out when we remove the H plus ions from the electrolyte. So it should remain red. It's a neutral solution. Ah, okay,
So
can.
for liquid solution,
Mm-hmm.
neutral, the
Mm-hmm.
color will be
Oh no, litmus solution can either will only have two colors, blue or red, yeah? Just like your litmus paper. Not universal indication. Universal indicator it is blue to green in color. Get it? Okay, so you might ask for 22, right? Now for question 22, you see we're using inert electrode. So we're going to write out what are the half equations that will happen at the anode and the cathode. So at the anode, we have the anion. Which anion to be discharged will be the hydroxide anion. So that is OH minus. Okay, and the cathode we will have the Cu2 plus ion to be discharged because of the copper 2 sulfate. Right, so it's Cu2 plus undergoing the reduction to form the copper metal. So what is the volume of the gas produced at the positive electrode? The gas that you're referring to is the oxygen gas. Okay, oxygen gas. And why is it that the negative electrode has an increase in the mass of 12 grams? It's because of the formation of the copper metal. So this is 12 grams. So you're going to find the number of moles of the copper metal first, taking 12 divided by 64. Alright? And when you sum up this half equation, you have to multiply this by 2. So in fact, for every 2 moles of the Cu2 plus ions discharged, there will be 4 moles of hydroxide ion and 2 moles of water, 1 mole of oxygen, and 2 moles of copper metal being formed. You know how to write this half equation? So we're going to multiply this by 2 throughout. So then we sum it out, the left side and the right side sum it out, we get this. So once you found the number of moles of copper, we're going to find the number of moles of the question wants us to find the number of moles of what? The number of moles of the oxygen gas, right? The oxygen gas at the positive electrode. So mole ratio is actually 1. So you take 12 over 64 divided by 2. Alright, and then after that, to find the volume of oxygen, this 12 over 64 divided by 2 and you multiply by the MR, you multiply by 24 again. Okay, so this should get you to the answer of D, 2.3. Anyone? Give it a try. This is the working. Okay, let's move on to question 29. So for question 29, there was no decomposition product at the electrode. That's the main statement. The bulk lighted out. So if there's no decomposition product, means that it must be in the simplest form, and therefore it must be an element. So it should be a metal element, and that's how we get mercury as the answer. 29.
not sugar because sugar cannot conduct.
Correct. Sugar is considered to be a non-electrolyte. It can't even conduct electricity in the first place. Same for the pure water, we discussed that last week. Pure water also cannot conduct electricity, but only the ionized water or the deionized water. Distilled water is considered to be an impure substance. Okay, next question, 30.
So it has to be non-metal.
Yep.
So it has to be a pure substance. Does it have to be a metal or it has to be a non-metal?
Cannot. Because all metal elements cannot conduct electricity. Yeah, so usually the metal, I mean, it must be the metal. Okay, good. Let's move on. Question 30. So which of the following has the nice job. So that's it. So why is the answer C? The answer is C. No, answer cannot be C. Ethanoic acid. Now C and D is totally out because we can see the ethanoic acid is a pure ethanoic acid. It exists as a covalent molecule, so it cannot conduct electricity at all, right? And D, sugar solution is definitely out as well. So we left with D because in A, can you see this word solid, lead bromide? Solid ionic compound cannot conduct electricity at all because they do not have any mobile ions. Yeah, so for such a question, nothing much to do. You just have to look up for the options and see which one are electrolytes and which are not electrolytes. Get it?
I think it's solid class.
Quite tricky. So sometimes I have to careful. Yes. Okay. Now question 31. Supply you any gaseous, not producers, products, capital area. Gaseous products. Oh, you see, when we use active electrodes, by now you should know that most of the time you will not get any gaseous product. Because if you use active electrodes, the anode will definitely get depleted, right? It will be oxidized. Alright? Okay, then what about the cathode? The cathode will get the gaseous product unless the N ions, alright, the N ions are chloride and it's in a concentrated solution. Okay? Or maybe hydroxide, but that is only for the aqueous solution, like aqueous acid, aqueous alkaline. So we use all these patterns to give us the answer to this. So just focus on the electrodes, the type of electrodes first. Then by now you should know that if you use copper 2 sulfate as an electrolyte, the copper 2 sulfate cannot yield any gaseous product at the cathode because of the discharge of the CO2 plus ion. The CO2 plus ions are very preferred to be discharged over the H plus ion. Yeah, so that's how we get the answer as D. Why? Because, okay, can you tell me what are the products we will get if you use a silver nitrate? At the, yes, silver metal at the, correct, at the cathode. Yes, correct, because you're using the copper electrode. Alright, so this kind of setup, eventually the electrolysis will stop once the copper electrode has been fully depleted because it takes an open circuit.
So then what?
So what you get in the solution, right, it will all be the CO2 plus ion. The means this solution will turn blue. The color of the silver nitrate solution is a colorless solution. Correct? All nitrates are soluble, right, in the water. So it is a colorless solution. So you get a blue solution in the end, and then you will get the silver metal. There is an increase in the mass of the copper cathode. So you're going to describe about the color. You will say that, okay, what's the color of the copper metal? Reddish brown. So there'll be a layer of a silver metal coated on the reddish brown copper cathode. Got it, right? So pH decreases most significantly means that it's becoming more and more acidic. Alright, so why is it C? So what will be discharged? Same thing, you know that the silver ions will be discharged at the cathode because this is more suited to be discharged than the H plus ion. So what's left in the solution will be H plus ion and the nitrate ion, which combines to give the nitric acid. So that's why the resultant electrolyte will be an acidic electrolyte. Correct, yes. At the end, note for this setup, anode, which is a carbon electrode, we will have the hydroxide ions to be discharged instead. Any mind? Hydroxide ions to be discharged because the nitrate ions are large N ions which are not preferred to be discharged at all. Okay, let's run through. So in A, using the platinum electrode will get depleted? No, because this is an inert electrode. So the N ion, sorry, the N ion to be discharged at the platinum electrode will therefore be the Cl minus, because you see this is concentrated. Hydroxide ions cannot be discharged, will be Cl minus to be filtered to be discharged. So you will get a yellowish green gas produced at the platinum electrode due to the formation of the chlorine gas. And then at the cathode, it will have the Cu2 plus to be discharged. Yeah. It's very, very likely to be Cu2 plus because, first of all, Cu2 plus is more filtered to be discharged than the H plus ion. And moreover, the concentration is very high. So there'll be a lot of Cu2 plus ions. So as a result, you'll see that there's an increase in the mass of the copper electrode. Okay? That's for option A. Oh, so the solution will be left with the H plus and OH minus. Alright, yeah, the water.
So then
The color will also be fading off from blue turn to colorless. Yeah.
how is copper to chloride?
Oh, wait, it's neutral. It's a salt. It's a salt. Chloride mass, right? Yeah. Okay. Right, so what about option B? In option B, now you see your copper is the anode. You will get a depletion in the copper metal. Right, so copper metal will get depleted. It will turn into the Cu2 plus ions. Eventually, you will see that the electrolyte will turn blue. So what about at the cathode? At the cathode, we'll have the H plus ions be discharged to get the effervescence of the hydrogen gas. So your final electrolyte will be coming blue solution of the copper to sulfate. And then for D, can you see this is an iodide solution? It's concentrated. So it follows the same electrolysis concept and the same electrolysis pattern as a chloride. So in fact, iodide will be more preferred to be discharged, right? So both of them are inert electrodes. At the anode, we have the iodide to be discharged to form the iodine. Alright, to form the iodine. Now, will iodine be aqueous iodine or will it be the gaseous iodine? It really depends on the surrounding temperature. Because you know the iodine will get sublimed. So if the temperature is high, then you should get a gaseous iodine, which is the purplish hue of the iodine. But if it's at room temperature, you know, like laboratory kind of setup for electrolysis, right? Then you'll get an iodine solution, which is reddish brown. So at the cathode, can Mg2 plus ions be discharged? No, because it's a reactive matter ion. So instead, you have the H plus ion to be discharged to get the hydrogen gas at the cathode. Yeah? Correct. You're left with magnesium hydroxide, which is actually a sparingly soluble alkaline, right? So you will get some kind of a blurry solution because of the formation of the magnesium hydroxide, but it will be white. Hmm. What is the color of magnesium iodide? It's actually a little yellowish, just like your lead-2 iodide. And then lead-2 iodide is a yellow solid, so magnesium iodide will also be yellow, but it is a soluble salt, so you will get a yellowish solution. 37. No change in the pH of the solution during electrolysis. So what is it saying? What kind of scenario are we talking about it here? That is the use of the active electrode to do the electroplating, right? Then we said that the C2 plus ions that are formed from the depletion or the oxidation of the copper anode will replenish for the loss of the C2 plus ions from the electrolyte at the cathode. And also in the end, there's no change in the pH, it will just remain the same. Of course. So if let's say we change the electrode to an inert electrode and using back the Cu2 plus CuSO4 solution, then you will have the Cu2 plus ions to be discharged and the hydroxide ions to be discharged, respectively at the cathode and the anode. So what's left will be the H plus and the SO42 minus. The H will decrease due to the remaining sulfuric acid is formed. Get it? Everyone okay following through? The next question. Yeah, sure. 38, yeah. Oh, rubidium is a group 1 metal, so it's even more reactive than the sodium metal. So you don't expect the rubidium ion to be rejected. So in this setup, what is happening is we have both carbon electrodes, which are the inert electrodes. So therefore, at the cathode, cathode will have the iodide ions because of the concentrated solution. So other ions will be discharged and the H plus ions will be discharged at the cathode. Okay, so that's why the answer for 37 is C. 37, yeah, 38. Sorry, 38, 38, the answer is C, yeah, C. Why C? Because positive electrodes is due to the discharge of the iodide ions that fuse to iodine solution, so it turns brown. And then the negative electrode is due to the discharge of the H plus ions that gives the hydrogen gas, which is a colorless gas. Right? The next question, 39. We're using iron electrodes. Okay, when we do a question, always check on the electrode first. So if it's an active electrode, we will definitely have what's happening at the anode. Yeah, so the iron will get depleted, will be oxidized to form the Fe2 plus ion. This is at the anode. Then at the cathode, what do you need to check? Check for the electrolyte. So the electrolyte is zinc chloride. Then you check cathode is cations. So you have the zinc 2 plus and H plus ions, which is more preferred to be discharged H plus ion, right? Yeah, so your H plus ions will be reduced to form the hydrogen gas. So which is false? Obviously A, because the positive electrode should be oxidized. Alright? And then you will get a green solution because of the formation of the Fe2 plus ion. So that's why C is correct. Then what about the pH of the solution? Why would it increase? Because we have removed the H plus ion. So what's left will be the hydroxide ion, causing the resultant electrolyte to become more and more alkaline. So iron 2 hydroxide. Yes, correct. Iron 2 hydroxide will be left behind. It will still be an alkaline, although it's sparingly soluble as a G2 So what you will see at the end of the electrolyte is just there'll be a lot of green precipitate in the electrolyte. It will still be able to conduct electricity, but then it will not be a clear solution. Okay, then the zinc ions are attracted to the negative electrode. Well, so why is that true? Because the zinc ion is the positive ions. They will attracted to the cathode. Now, this will only happen when the H plus ions are fully discharged. Then you will have the zinc 2 plus ions to be discharged in the end. Right? So next question 40. Okay, this is the hardest question. You see, they bold the word always takes place when copper 2 sulfate is electrolyzed. So you have to take into consideration the use of the active electrode and the use of the inert electrode. Alright? So whether you're using active or inert electrode, the copper will always be deposited at the cathode. Let's say we use the active copper electrode, right? You will definitely have the CuC plus be discharged because it's more preferred to be discharged as compared to BH plus ion at the cathode. So you will get copper form. Then if let's say you use the active electrodes of copper or maybe silver or other metal electrodes, you will also get CuC plus be discharged at the cathode. So that's why this statement is always true, will always take place regardless of the types of electrodes that you use. So to decide what type of product we get in the electrolysis, the type of electrode used are very important. Okay, so these are all the practice questions for electrolysis. So along the way, when we are doing revision, there'll be more questions on electrolysis as well. All right? Any questions? Okay, good. So we're going to go into the organic chemistry. Any questions, Iman? What is think of? All right. If there are, you can please text me. Oh, just you remember what are the reactions of the alkenes? Alkenes undergo the, because it's an unsaturated hydro.
Hydrogen.
All the three things, right? Yeah.
How about the last one?
Halogenation. Always remember the alkanes and the alkenes will react with the halogen. Right? Okay, so today we're going to talk about isomerism. I understand that we have done question 3, 5, and 6 from worksheet 6.2, worksheet 6.2. So what do you mean by isomerism? I think last week we discussed about that, right? But I'll give you more examples. You also know that the molecules, when they get bigger, especially for organic molecules, they will tend to take on different forms, right? Different arrangement to get themselves be more stable, right? Due to the increasing size of the molecule. So usually isomerism will happen when the molecule has 4 carbon atoms and above, right? 4 carbon atoms and above. So let's say, let me change the screen. Okay, so if you look at this molecule of the pentane, pentane is C5H12. It has 5 carbon atoms that are joined together, right, to form the carbon chain. Okay, the rest are all hydrogens. So because the chain is quite long, they can actually shorten it to get it to a 4 carbon chain, right, and have a carbon that branches out from the main chain. So this is another arrangement. Oh yeah, Iman, are you doing organic chem now in school? You have already started, right? Which part
Yeah.
of it are you doing now?
That like we just like finish polymerization.
Oh, the alkene polymerization, is it?
Yeah.
Okay,
Yeah.
okay. Addition polymerization.
Yeah.
Yeah, that one I'll cover it later. All right. So we'll talk about isomerism first. Now this is one of the isomer for pentane. You can see from a 5 carbon chain it has shortened to a 4 carbon chain. And what about the 5th carbon is that it will branch it out from here. Alright. Now we can also have a 3 carbon chain and then it branches out like that. Okay. So these are the different types of the arrangement. Okay, let's run through some other possibilities. Do you think it's possible to have this? Is this considered to be one of the isomer? This one. This one is not an isomer. Although it looks different on paper, right? But don't forget, all these molecules are three-dimensional. These two are the same. Alright, they are not isomers. Yeah. So when they are the same, we said that they are not isomers. Why are they the same? Because if if you visualize this in spatial format, right, you can turn the whole molecule, then you still give you back this one. Fair enough. So they are not isomers. Alright, now what about this? If I put my C carbon here, is this considered to be an isomer? Also not isomer because this single bond can be rotated. You can rotate it up and then it gets you back to a straight chain. So this and this are the same. Very hard to visualize, right? Because it's all three-dimensional. Now give me a minute, I'm going to get my model. Right, so now due to the time constraint, I'll just do one part of it. So this is the pentane. So 1, 2, 3, 4, 5 carbon are the black atoms, all right, and then the hydrogen are this. Now when I draw it on the paper with this carbon facing down, right, it's actually taking on this type of arrangement. So it face down, they just turn. All right, now all this shape are not straight chain. It's not like a flat shape. It's actually linear. It's actually a three-dimensional. You see that? So when it's pointed up, it means that it's actually the carbon is actually on paper, it's actually pointed up like that. Okay, when you see this line here, it's going up, right? So when it's going down, you can turn it down like this. Or you can turn it down like that. It's really hard to show you. Okay. So this is down. If you see this is down, alright, and then up is like this, up. So you see this is the single bond, the CC single bond. It can be rotated. Did you see that? So on the paper, we can draw it as 90 degree or straight chain or perpendicular, but in actual fact, it looks like that. It's actually not 90 degrees there. It's actually 60 degrees. Alright, so if it's up, it'll be like that. If it's down, it goes down like this. But whether it's up or down, it will still be a straight chain, a continuous chain. But to get it to this structure, you need to break one of the carbon bonds and put it here. Then this is an isomer. Understand now? Which has a total different structure as compared to the straight chain one. No matter how you turn it, you can never get it to this straight chain. That's the meaning of the isomer. Understand, Sam? Right? Yeah, so on the paper, if you see this type of L-shaped chain, right, it means that this can be rotated and straighten it into the same structure, so this cannot be an isomer. Yeah. So the only isomers for the pentane will be this, and this. There are three isomers. Got it? That's what isomerism is all about. Now we call this as different structural arrangement. Now what about alkene? Alkene, let's see a C4H8, that's the butene. Now alkene will be a different thing already because the CC double bond cannot be rotated. Alright, so you can see that this is a double bond. Right, a double bond, it cannot be rotated because it's being restricted by these two covalent bond already. Right, so what will be the isomerism concept about the alkene is that it has a change in the position of the functional group, such as this. They are considered to be isomers. They are different. Okay, they are different. For example, we call this as a but 1ene. This, the second one, is called but 2ene. The 1 and the 2 are put in between the names because of the functional group. The ene stands for the functional group of alkene. So 1e means that the double bond is on the first and the second carbon. Whereas 2e means that the double bond is on the second and the third carbon. Okay? Okay, what about the other one is, we can also shorten the chain. For example, We can shorten it to a 3-carbon chain and then have a branch. Yeah. So this structure is definitely different from the straight chain structure. So we call this as 2-methyl propene. Or it will still be an alkene, but it's a propene because the main chain is 3-carbon chain. And it's a branch, so it's got 2-methyl propene. The branch is on a second carbon, so that's how it gets the number 2. The numbering a little confusing, but you all will get used to the language of this organic compound. Now the 2 stands for the position which the branch is in. Remember we talk about branches? Okay, the branch has the general formula of CnH2n plus 2. So you see this is a branch. Why? Alright, so this is a branch because the branch contains 1 carbon and 3 hydrogens, which fulfills the general formula of a branch, the substituent. You see now when n equals to 1, it gets you to CH3. We call this as a mean, and this is a methyl. Because the general name for a branch is the alkyl, or the family name is alkyl. So it's methyl, n equals to 2, C2H5, this is methyl. So what are branches? Branches are those substituents that are attached to the longest carbon chain. Now since this is the longest carbon chain because it has 3 carbon atoms, then we'll consider this as a branch. Just like in the previous example for pentane, you see this pentane? There is a branch here, right? The branch consists of 1 carbon, so it's a methyl. And what is the longest chain? The longest chain has 4 carbon atoms. You see the longest chain has a 4 carbon atom. So 4 carbon atoms chain is called a what? Bute, right? So it's a butane. So how do we name this compound? Since it has a branch and the branch is on a second carbon, so we call this as a 2-methyl butane. So when you do a naming of an organic compound, you must name the branch, you must name the longest chain, you must also put in the numbering of that branch, the position of the branch. So first of all, you look out for the longest chain first. Right, longest carbon chain is 4. So it must be a bute. And then you look out for the functional group. Since they are all the CC single bond, it belongs to the family of the alkane. So it is called as a butane. Alright, so then watch out for the branch. There's only one branch here. One branch is made up of 1 carbon atoms. So it will be a alkyl and a methyl. And because this branch is on the second carbon, we put a numbering for this branch, so it's called 2-methyl butane. Okay, 10. Alright, so some students will ask, how do I know that this one is the longest chain? Maybe I can also go this way, right? Go like that. Go down. Can, but then here, if it goes down this continuous chain, there are only 3 carbons, so it's still not the longest one. You must get the longest continuous carbon chain. Okay, so let's see if I have a hexane. Oh, that's more complicated. Yeah. This one like pentane, is it? This one. Yeah. How do you name that? Longest chain? Longest chain is 3. Can go like this. Can go in a horizontal way, or you can also go vertically, right? Either direction will give you 3. So the base name will be the right? Propane. Okay, then we look at the branches. We have a branch here. We also have another branch here. The branches are put separately but on the same carbon atom. So this is called a methyl. For each of them, it's called methyl. There are 2 of them, so we call this a dimethyl. Right, so it's called dimethyl right, the unequal. And how do I position? This is the position of this two methyl group. You can see it's on the second carbon. Both are on the second carbon. So it's got two dimethyl propane. 2, 2. Okay, so it's 2 dimethyl propane. Now this is not an ethyl because the branch are put separately, one up, one down. And in each branch, there's only one carbon atom, so it should be a methyl. Ethyl will be like that. Okay, so I use this branch, and then there are 2 carbons like that. This is called an ethyl. Okay, so how do we name this compound? Now, where is the longest carbon chain? Is it the horizontal one or is it the L shape? Horizontal, how many carbon? 1, 2, 3, 4, 5, 6. Horizontal, then if you go vertical, L shape is only 5, right? So it should be the horizontal one as the longest chain. That's called hexane because there are 6 carbons. So it's hexane, something hexane, right? So now we have to name the branch. So look at this branch here. The branch is a 2-carbon branch. It's joined together continuously. So 2-carbon branch is known as an ethyl. So the ethyl hexane. Right, ethyl hexane. Then which position is this ethyl in? Yeah, so it's 3 ethyl hexane. Got it? When you give the position, you have to give the lowest number. Don't count the carbon from right to left because with right to left it will be 4. 1, 2, 3, 4. Yeah, but there are situations whereby you have to count it from right to left. So you have to check. Like if let's say this ethyl is in this branch is here, then this will be known as 2 ethyl hexane. You're going to count it from right to left. Not 5 ethyl hexane to 2 ethyl hexane. Don't forget, these molecules are 3-dimensional. Turn it, it will be on the second. Okay. And then these 2 ethyl hexane and the 3 ethyl hexane are isomers. They are not the same at all, although they have the same chemical formula. Okay? So you see, there will be more and more isomers if the molecule gets bigger. There are more possibilities. Remember for alkenes, the position of the CC double bond will also considered to be isomers. You can also shorten the chain as well. Yeah, these are the different ones. Oh yeah, one more thing is, now isomers may not be referring to molecules that are from the same functional group. We can also have molecules from different functional groups. For example, the butene can also have isomers that look like this. Okay, I'll draw another picture. The C4H8. Okay, you see C4H8 is the butene, right? But it can also have an isomer that is in the different functional group. Like that. You're still with C4H8, but this is not an alkane. But instead, this is an alkane. Right, and what do we call this alkane? This is known as a cyclobutane. Right, now the word cyclo is used to describe cyclic structure. We call this a cyclic structure of the hydrocarbons. So what are cyclic structures? That means the carbon chain are all interlocking with one another to form a ring structure. Now, good to know this because there are more and more prelim questions that talk about cyclic structure, the cycle compound. So whether is it a cycle compound or the non-cycle compound, the strict chain compound, Once it is an alkane, it will always follow the same chemical reactions. That means the cyclobutane can also undergo the substitution reaction with halogen. Right? It's just that this is also considered to be an isomer. The definition of isomers, right, is just defined as different structural formula but same chemical formula, but they never say they must be same functional group. Got it? So they can come from different functional groups as long as their structural arrangement are different and then the chemical formula are the same, they are considered to be isomers. Okay? Alright, so since now we have talked about the cyclo compound, cyclic structure, let's see if I have the cyclobutane, C4H8, cyclobutane as what I've drawn here, and I react it with a chlorine. It will undergo the substitution reaction because this is an alkane. So what does it do? It will replace one of the H, right? You can replace any H. With a Cl, so I replace this H with a Cl, and I get it to a HCl as a byproduct. You see, the pattern of the reaction is still the same as what we have discussed in the previous chapter for the alkene. Okay? How do we name this compound? It's known as a chlorocyclobutane. Because once it's being used as a substituent, the halogen will now be termed as the cyclobromo fluoro iodo. Yeah. So the name of the halogens have to be changed with a new suffix that ends off with O. Yeah, so all these are application questions.
Like
Any topic? Because the topics are, you can see organic questions, organic compounds in some of the other topics like new concept and also in the matters, the chapter of matters, and even application and stuff. Actually, it's quite important. When you look at the A level, the weightage of organic is very high. Almost 1/3 of the syllabus covers the organic chemistry. Yeah. And also the organic chemistry for A level requires actually a bit demanding, quite time demanding. You need to do a lot of practice for that. So that's why the O level organic chem, the fundamentals have to get it right first.
also last week that
Yeah,
what is that?
yeah, lor. I also pity them. So now when I teach the day one, right, I have to take up about an hour or so to cover all the fundamentals of the organic chem for them. Because they actually start to there are a lot of questions in the first few topics for J1 that involves organic compound. So when you see the questions, you do not know what are they. Because they've not learned the organic chem in the A level. So a little part like in the start. Okay lah, we got it through. So yes. Okay, Iman, any questions? Any more questions, Elisa? No, all right. Okay, let's try. Let's try a few. You look at question 4. Could you tell me, question 4, there are 5 structures, and they want you to identify which compound or which molecule are the same. Now, when you say that the molecules are the same, are they isomers or are they not isomers? Isomers, right? They are the same means that they are not isomers. Isomers means that they must have different structural arrangement. Right, Iman? So which are the same structure? Spreadsheet, right? Let's start a little. Use the eye power to see. 2 and 3. Are 2 and 3 same as 1? No, right? Very good, Iman and Melissa. So you all agree 2 and 3 are the same. Good. Any more? 5 as well, right? Yes. Okay, so the answer should be 2, 3, and 5. You see, for 5, why do we consider this as the same molecule as that of 2 and 3? That is because we can actually turn this bond here. Okay, we turn this bond, this one. We turn it upwards, we'll get you to this structure, this one. You see? It's like a number 4. The bond is like a number 4. So you turn it up, and you split the whole molecule, so you turn it back to 2. Got it? Then now, so this one turn outwards. So 2, 3, 5 are the same, they are not isomers. But then 2, 3, 5 together with 1 and 4 are 3 different types of isomers of the pentane. This is the pentane. 5 carbon, you see 5 carbon chain, and all CC single bonds, so it's an alkane, so it's a pentane. Yes, you realize something. Okay, now question 15. For question 15, you can see that all of them are isomers of each other. Right, all of them are isomers of each other. How do you check? You must count the total number of carbon, hydrogen, and oxygen. Make sure that they're all the same to give the same chemical formula. So you should have a C3H8O. The chemical formula is C3H8O for all the 3 of them, but they have different arrangements. Right? Yes.
So isomers can include other elements.
And include other functional groups. Oh yeah, of course, can include other elements.
Oh.
Yes, this is not just in C and H. I mean, it's not just in hydrocarbons. Isomers exist in all types of organic compounds. So when we move on to alcohol, carboxylic acid, they also have their own isomers. So we need to start off with the fundamentals of isomerism first. Then after that, when we move on to the later chapter, we know how to use isomerism. Yeah, explain to you to your friends. Okay, after more practice, you'll get it. Yes. Okay, you see, this is an alcohol. This alcohol is represented by the OH functional group. So in the third chapter, when we discuss about alcohol, you see that the alcohol has this OH as a representation for the functional group. Alright, so these two are two different structures because the position of the functional group are different. You see this OH is attached to the first carbon, but this functional group is attached to the second carbon. This is something like the alkane. Remember just now we said that the alkane can also have isomers when we change the position of the functional group. Alright, so these two are alcohol. But for the compound C, this is not an alcohol. Compound C is known as an ether. You see this O here? It has a different pattern. It's an OO single bond to 2 carbon. Ether is denoted by a C-O-C functional group. Whereas alcohol is denoted by an OH functional group. The O and H must be together. So even though they have different functional groups, as long as they have the same chemical formula but different structural arrangement, we will consider them to be an isomer, to be isomers. Yeah? All three has a chemical formula of C3H8O. Correct? questions? Okay, so I will stop here today. You should go back